right triangle. So this is the final thing we're going to do, is where I'm going to be able to give you a triangle, and you're going to tell me all three sides, all three angles. Depending on what I give you, you have options on how you're going to solve for stuff. So to solve a right triangle means to find the measures of all, put that in capital letters, all of its sides and angles. So three sides, three angles. We're only going to be solving right triangles. If it was any other kind of triangle, we couldn't do this, but for right triangles, we can do this. So you can solve a right triangle if you know either of the following. So either you know two side lengths, or you know one side length, and the measure of one acute angle. So you know either two side lengths or one side length and the measure of one acute angle. We have to specify acute angle because obviously a right triangle, you always know one of the angles is 90 degrees, right? But we want to talk, then you need to know a second angle on top of that, and it has to be that acute angle. So you can imagine this would be pretty helpful anytime you have to build anything. My husband, one of his random quarantine, because he's been working from home since last March, one of his random quarantine things is that he loves building now. He's got like a whole wood shop downstairs in our basement. And so he often, honestly, asks me questions about triangles, and I've had to, crack out my trig functions every once in a while. It is one of the more applicable things that we do in geometry and math classes in general, is this stuff with right triangles, especially for building purposes. So we've talked about using these trig functions for finding side lengths, but it turns out you can use trig ratios to also find angles. Now these are a little different trig ratios. These are inverse trig ratios, meaning they're going to undo one of our trig ratios that we've talked about. So inverse trigonometric ratios, we have this picture here and it says let A be an acute angle. So we're talking about this angle right here. The inverse tangent function says that if A is equal to x, then tangent inverse of x is equal to the measure of angle A. So I'm just going to put right above here, this is read as tan inverse or tangent inverse of x. So what I don't want you to confuse is this is not raised to the -1 power. This is strictly a notation. I don't know if you guys remember, but raising to the -1 power flips something. So if you have x to the -1, that's the same as 1 over x to the first. That is something different. This is just a notation. It's just the notation that they chose to use for this, and it's just read as the inverse tangent or tangent inverse of x. I always read it as tan inverse, just because that's the order I see it, but technically it's inverse tangent of x, but either way is fine. So again, don't confuse this with tangent raised to the -1. That's not what it is. You should read it as tan inverse or inverse tan. So notice that in this little function here, we're used to seeing tangent of an angle equal to BC over AC. Notice when you're using the inverse function, this is your sides instead of the angle, and it will equal your angle. Versus what we did in 7.6 and 7.5, this was our angle, and this was our sides. You want to make sure that you know that difference there, and I'm going to try and really pound that in by making you guys enter, when you do on Go Formative tomorrow, I'm going to make you enter an angle, whatever equals, and you'll have to use degrees and all that stuff. So, since there's an inverse tangent function, there's also an inverse sine function and an inverse cosine function. So the inverse sine function, if sine of A equals y, then sine inverse of y equals the measure of angle A. Likewise, inverse cosine, if cosine of A equals z, then cosine inverse of z equals measure of angle A. So example 1 wants us to use an inverse tangent to find an angle measure. Specifically, this wants us to use a calculator to approximate, and this is an approximation, but to approximate the measure of angle A to the nearest tenth of a degree. So we're looking at this angle A. So just like we did in 7.5 and 7.6, relative to that angle, you should name the parts of the triangle that we have. So this 15 CB, this is our opposite. And AB is our adjacent. We have opposite and adjacent. Which trig function should we use? Tangent. Yeah. So just like in 7.6, you guys can start by setting up just a normal trig function. So we can say tangent of A is equal to our opposite, which is 15, over our adjacent, which is 20. Everyone comfortable with that setup? We've done it a lot at this point. Okay, here's the weird part. Now, the inverse function, we're going to flip everything. So basically what you're doing, the intermediate step, and you guys don't ever have to write this step again, but what we're doing here is you're doing tangent inverse of tangent of A equals tangent inverse of 15 over 20. 15 over 20. So this step you never have to write again, but what's happening here is that this tangent inverse and tangent undo each other. That is the definition of an inverse function. It undoes whatever the function is. So if you think about like a square, right? If you have x squared, we undo a square with a square root. And that's because those are inverse functions. So that's why this tangent inverse undoes the tangent. So what we're left with is A equals tan inverse of 15 over 20. And so that middle step where I wrote those arrows, you never have to write that step again. I just want to show you why that is. But you're taking the tangent of A, flip it around, and you make it the tangent inverse of your sides equals the angle. Make sure you don't mix up tangent inverse. All of your inverse functions operate on sides to give you an angle, versus all of your regular trig functions operate on an angle to give you a ratio of sides. Okay, so all of that being said, where is this in our calculator? So in your calculators, all this stuff, make sure you're in degrees, still in degrees. Okay, you can see on your calculators, if you have a TI, you should be able to see there's like blue options above all of the regular buttons, right? So if you look above tangent, your tangent button, in blue it says TAN to the -1, that's your tangent inverse. So anytime you want to get to a blue option, you hit second, tangent, and you should get tan inverse. Is anyone not seeing that or not able to find it? Second tangent gets you that tan inverse. You have a parenthesis, so then you just type 15 divided by 20, close your parentheses. So tan inverse of 15 over 20. Hit enter, you should get 36.869897645. We're going to round to the first decimal place here. So it's 36.86. 6 is bigger than 4, not bigger than 5. So this is going to round to 36.9. Remember, A is a degree, an angle. So it's angle A is equal to 36.9 degrees. On your Go formative homework today, I'm making you guys put the degrees because I really want you to remember that we're solving for an angle here. Okay? Any questions about this one, or we're not sure where something came from? Okay, so example 2, just further practice with our calculator. Use an inverse sine and an inverse cosine. So let angle A and angle B be acute angles in 2 right triangles. Use a calculator to approximate the measures of angle A and angle B to the nearest tenth of a degree. So again, to that first decimal place. So part A, we have sine of A equals 0.87. So this time they didn't give it as a ratio, they didn't give it as like a fraction, they just gave it as the decimal, totally fine. So to undo that sign, we take the sine inverse of both sides. And again, I'll write this intermediate step. So you have sine inverse of sine of A equals sine inverse of 0.87. And I'm just going to write this intermediate step for today. Tomorrow we'll drop it. So that simplifies to these signs undo each other. So that you have A equals sine inverse of 0.87. Back to our calculators. So right above sine this time, we should see a sine inverse in blue. So you hit second sine, that gives you your sine inverse. You can either put 0.87 or put 0.87. Close your parentheses. Round it to the first decimal place. So we have 60.4586394999. This would be 60.5 degrees. So we have A equals 60.5 degrees. Did anyone get anything different? So part B, just so we know where the cosine inverse is, we have cosine of B equals 0.15. So again, our intermediate step that I'm writing for today, but will not write tomorrow, is cosine inverse of cosine B equals cosine inverse of 0.15. That cosine inverse and cosine undo each other. So that we just have B equal to cosine inverse of 0.15. In our calculator, cosine and inverse cosine share a button. We just have to hit the second. So back to your calculators. Second cosine gives us that cosine inverse of 0.15 or 0.15 should be 81.3730734413. If you round to the nearest decimal, it'd be 81.4 degrees. Did anyone get anything different?
Like the first three, like they match yours, but then the rest, like, don't. Is that
Yeah.
yeah.
All right, so that's the only thing I want to do today. I want to make sure we're good with using these inverse. Tomorrow we'll talk about example 3 and 4, where we're going to go through and solve the entire triangle using everything we've done in this chapter, and actually in past chapters as well. Not today, no. Stop.